Okay, after doing the problems on the lenses, that is lens formula and magnification, now only the left out the problems is on refraction, that is refractive index, and Snell's law, that is refractive index in terms of the refractive index of the two medium, as well as how to express the refractive index in terms of the velocity of light in the two mediums. When I speak of two mediums, means it is denser, rarer medium and denser medium, and you know that velocity of light in rarer medium is always greater than the velocity of light in denser medium. That's why velocity of light in air is always greater than the velocity of light in water, or velocity of light in air is always greater than the velocity of light in glass. Compared to the refractive index of air, glass is having higher refractive index. Again, compared to the refractive index of air, water is having the higher refractive index. So as the refractive index increases, the velocity of the light in that particular medium decreases. Wherever there is decrease in the velocity of light, when it comes to the relative velocities comparison with the other medium, that is always will be the denser medium. That is, wherever the lesser the velocity of the light, the greater will be the refractive index, and that medium will be the denser medium. Wherever the velocity of the light is higher, there the refractive index will be lesser, and that becomes the rarer medium. So we have all seen this, and we have also seen this Snell's law. Okay, now we shall just brief up the formulas here. This is for the problems. Now you can see here, refractive index is equal to the ratio of C by V, that is speed of light in air to the speed of light in any medium. It may be any medium, water or glass, but the numerator is speed of light in air. Speed of light in air, speed of light in vacuum, or speed of light in free space, or together it is equal to 3 into 10 power 8 meter per second. Okay. Now, in certain textbooks, this refractive index we have written with the letter small n. In few textbooks, they have also used a Greek notation called as mu. Okay, we call it as mu. You can see here, we will write like this. This is called as mu. That mu is also refractive index in certain textbooks. It is also given by C by V, same formula, but here it is Greek symbol, that is mu. Now, as I told you, refractive index of free space, or refractive index of vacuum, or refractive index of air is equal to 1. Then, how to spell this? Refractive index of medium 2 with respect to medium 1, or we can even write this as N21. Okay, we can even write this as N21 also we can write. Refractive index of second medium with respect to first medium, which is equal to the formula N2 by N1. So second medium should come first, first medium should go in the denominator. And you know that refractive index is always inversely proportional to the velocity. You can see here, they are inversely proportional to the velocities. That's why in the numerator you have 2, 1. See the velocity, you have 1, 2. So N2 by N1 is equal to V1 by V2. Now again change this, rarer and denser medium. Now see here, refractive index of first medium with respect to second medium. I can write this as N1, 2, which is equal to N1 by N2. So how about velocity? Here numerator 1, denominator 2. So for velocity, numerator 2, denominator 1, because inversely proportional. Then the Snell's law. This is Snell's law. Okay. Refractive index of medium 2 with respect to medium 1 is equal to refractive index of medium 2 to the refractive index of medium 1, which is equal to the sine of angle of incidence to the sine of angle of refraction, ratio of sine of angle of incidence to the sine of angle of refraction, which is also called as Snell's law. Okay. Now you know that the relative refractive index between two medium, any two medium, one being the rarer, the other being the denser, or vice versa. If you multiply, it is always equal to 1. That is, you can see here, refractive index of second medium with respect to first medium into refractive index of first medium with respect to second medium is equal to 1. Or we can say that both are reciprocal to each other, because this goes to denominator means both are reciprocal to each other. Now, one more concept is there, how to express this refractive index of two mediums. Say refractive index of water with respect to air is equal to real depth by apparent depth or apparent depth. What do you mean by real depth by apparent depth? Now you can see a simple experiment I will tell. Now take a glass beaker filled with 3/4 of water. Just drop a coin, a 5 rupees coin, okay? And if you observe it in front view, what you will get? Not only the coin appears bulge, it appears if you hold it down, okay? And if you are observing from the top obliquely, the coin appears to be raised. Actually the coin is settled down at the bottom. That is actually means what? That is the real thing that has happened, that the coin has, due to its density, due to its weight, it has settled down in the bottom. That bottom is called as real depth. Now where you have to measure the real depth? From the surface of separation between the two mediums, that is air and water. This is the top surface which separates air and water, right? From there the coin is exactly at the bottom. That is real. That is called as real depth. Okay, now you can see here. This is real depth. Now what is apparent depth? If you are holding the same apparatus and if you are observing from the top, actually the coin appears to be raised, right, at this position. Now this depth is called as what? Apparent depth. Okay, so refractive index of water with respect to air can also be expressed as a ratio of real depth to the apparent depth. So these formulas you have to remember for the problems. Thank you. Now the first problem you will see. Light travels through water with the speed of 2.25 into 10 power 8 meter per second. What is the refractive index of water given the speed of light in vacuum is equal to 3 into 10 power 8 meter per second. So here you have to find out the refractive index of water. The basic formula you have to use. Okay. Now speed of light in vacuum means speed of light in air or speed of light in vacuum. Generally what is given? So you have C is given, that is 3 into 10 power 8 meter per second. Speed of light in air or vacuum. Now speed of light in any medium. Any medium means what? The medium is water. The denser medium is water now. In that water the light is moving with the speed of how much? That is V. 2.25 into 10 power 8 meter per second. Now what you have to find out? What is the refractive index of water? Means refractive index of the second medium. Now you know that the formula, that is N is equal to C by V, or N is equal to C is what? 3 into 10 power 8 divided by 2.25 into 10 power 8. Now for many of you, the simplification, what you have to do is, you have to be very careful, okay, how to simplify it. Now 10 power 8 get cancelled. Now N you got here 3 by 2.25. Now it's better that you make 2.25 a whole number, okay, by removing the or by shifting the decimal point. Okay, how to do that? You can see here N is equal to, write this 3 as it is. You know that 2.25 after decimal point, how many places? 2 places. So this could be written as 225 divided by 100, right? 225 by 100. Now, by taking the reciprocal, this goes to the numerator, right? N is equal to 3 into 100 by 225. Now, you can just simplify. Or 300 by 225 is also correct. Let us go with the 5 table. Okay. 5 20s are. Then here, 5 4s are, 5 5s are. Then, 5 4s are, 5 9s are. Then 3 1s are 3, 3 3s are 9. So what you get? N is equal to 4 by 3. 4 by 3 means what? 1.33 is the recurring decimal. So that is recurring. So N means what here? Refractive index of water. So what you have to find out? Refractive index of water is equal to 4 by 3, which is equal to 1.33. Now we understood the simplification. Okay, thank you. Now second problem. Light travels from a rarer medium 1, that is first medium, rarer medium, maybe air, to the denser medium 2, maybe water. Okay. The angle of incidence and refraction are respectively 45 degree and 30 degree. So angle of incidence is given, angle of refraction is given. Now you only should think which formula I have to use. Calculate the refractive index of the second medium with respect to first medium. So when you have been given the angle of incidence and angle of refraction, and to find out the relative refractive index or the refractive index of denser medium with respect to the rarer medium, means obviously you have to go for the Snell's law, right? So this is based on Snell's law. So from Snell's law, okay, or else you can write the given data, okay, what it is given. Now what it is given, angle of incidence, that is I is given 45 degree, then angle of refraction, that is R is given, R is how much, 30 degree. Now we have to find out refractive index of second medium with respect to first medium. So refractive index of second medium with respect to first medium, which is nothing but N2 by N1. Okay, N2 by N1, which is also equal to sin I by sin R. Okay, how to find out sin I by sin R. Now take any one, that is refractive index of second medium with respect to first medium, which is equal to, don't write this because this is equal to this only. So this is equal to sin I. You know that sin means trigonometry. In mathematics you will learn, okay? That is trigonometric ratios and how to express the trigonometric ratios in terms of standard angles. Sin 0, sin 30, sin 45. Okay, sin 60, sin 90, sin 180. Similarly, that follows for cos, tan, secant, cosecant. Okay, all the 6 trigonometric ratios are expressed in terms of standard angles. Now, this is equal to sin I. Sin I means angle of incidence is given, that is sin 45 degree divided by sin angle of refraction is 30 degree. Okay, from the concept also you should be very careful that always angle of incidence is greater than angle of refraction. Why? Because at angle of refraction the angle moves towards the normal, that's why angle decreases. Now what you will get, now these values you will learn in mathematics. Okay, sin 45 degree is 1 by root 2 divided by sin 30 degree is 1 by 2. Okay, so what you will get, 1 by root 2 into taking the reciprocal, you will get 2 by 1. Or refractive index of medium 2 with respect to medium 1 is equal to 2 by root 2. So the answer what you are getting is 2 by root 2. Or else you can see here, you can still simplify this further. How means, you can see here, this 2, this numerator 2 can be represented as or expressed as root 2 into root 2 divided by this denominator root 2 is there, you write that, then root 2 get cancelled, so you will get the answer square root of 2. So this is the answer. Okay, what is the answer? Square root of 2. So the refractive index of second medium with respect to first medium is square root of 2. Moving to the third problem, very interesting problem, just observe here. How much time will light take to cross 2 millimeter, 2 mm thick glass plane if refractive index of glass is 3 by 2? Okay, they have given in the ratio, that is 3 by 2. Now see, I have drawn a glass slab. You know the glass slab will be like this. It is like this, right? That's some thickness. This is the glass slab. It is having some thickness on all the sides. And the thickness will remain constant. Just like this I have drawn here. It is having some thickness. Okay. That thickness is given 2 millimeter. In millimeter it is given. Obviously I have to convert it to meter. Later we will do. Observe that. Now, in this glass slab refraction will happen. We have seen the refraction through the glass slab. Twice the refraction will take place, right? Now see here, these marked lines. This is one opposite face, this is the other face. Now at here, at this interface, one refraction, the refracted ray will travel and it will hit the other interface, and finally the ray emerges out, what we call it as angle of emergence, which moves away from the normal. Why? Because rarer, air is the rarer, glass is the denser. Rarer to denser, refracted ray moves towards the normal. Denser to rarer, the refracted ray moves away from the normal. So this concept we know that. Now, that glass is having 2 mm thickness. You have to find out how much time will the light take to cross 2 mm thick glass plane. Means the light will enter at this surface, top surface. It will undergo the refraction and it will exit out of this bottom surface outside. So to pass this thickness, 2 mm thickness from top surface, enter into the glass, leave out of the glass from the opposite surface, how much time it will take? So that is the question. Okay. Now here it is given refractive index of the glass. Okay. Now you know that the formula is N is equal to C by V. C is the speed of light in air. You know that value. Refractive index here means of second medium. Second medium means glass, that is given. N of glass is given. You have to find out the speed of light in glass. First we have to find out that. After finding out the speed of light in glass, then you can find out the time. Why? Because speed is equal to distance travelled by time, or time is equal to distance by speed. You can apply that formula. Now N is equal to C by V. Okay. Therefore you have to find out V. Therefore V is equal to C by N. C is given, that is 3 into 10 to the power of 8 meter per second. That is speed of light in air, we know that. Refractive index of glass is given, that is 3 by 2. V is equal to 2 will go to numerator. 6 into 10 power 8 by 3. 3 ones are 3 twos are. So speed of light in glass is what? 2 into 10 power 8 meters per second. As I told you, always the speed of the light decreases when it enters to the denser medium, that is the glass medium. Now you got this. Now you have to find out time. Now you have the speed, you know the thickness. That thickness is nothing but, this thickness is there, right? This thickness, light will enter from here and it will go from here. This thickness is nothing but distance. That is the distance. Which is travelled by the light. Okay, so the distance is nothing but thickness here. Now that thickness is given, that is nothing but, it is the distance only d, which is equal to 2 mm. So 2 millimeter, convert it to meter. 1 meter is equal to 1000 millimeter. Therefore 2 millimeter is equal to 2 into 10 to the power of minus 3 meter. Okay, 2 into 10 power minus 3, or 2 by 1000. 2 by 1000 means 2 by 10 power 3. Bring the 10 power 3 to the numerator using the exponents. Okay, you will get 10 power minus 3 meter. Now you have distance, that is thickness. You have speed. You can easily find out time. Therefore time is equal to what is time? Distance, that is thickness by speed. So what you will get time? D is equal to distance or thickness is 2 into 10 power minus 3 divided by speed is also given 2 into 10 power 8. 2 cancels, then T. If 10 power 8 goes to numerator, if the power goes to numerator means that plus 8 will become minus 8. So what you will get? 10 power minus 3 into 10 power minus 8. Now base is same, you can add the powers. What is that? 10 power minus 3 minus 8 minus 11. So time is 10 power minus 11 seconds. Unit of time is seconds. Understood the problem? Okay students, moving to the next fourth problem. The refractive index of glass is 1.6 and that of diamond is 2.4. Calculate the refractive index of diamond with respect to glass. First write the given data. Okay, what refractive index is given. Now there are two medium here. One is glass, the other one is diamond. Okay. Now refractive index of glass is given, that is Ng. You can even take mu g. Okay, mu is also the Greek symbol to represent refractive index. Don't get confused. Okay. So Ng is equal to how much? 1.6. Then refractive index of diamond, Nd, I will take diamond as small d, is 2.4. Then you have to find out refractive index of diamond. See, second medium, diamond with respect to glass. Glass you should write top. Okay. So what is that formula? You know that? Which is the formula? refractive index of second medium with respect to first medium is equal to N2 by N1, which means refractive index of diamond with respect to glass is equal to refractive index of diamond by refractive index of glass. Okay. Now, refractive index of diamond with respect to glass, that is equal to, what is the diamond? That is 2.4 by 1.6, or you can write this as 24 by 10 by 16 by 10. 10 cancels. What you will get? 24 by 16. So, Three by 2 you will get. Refractive index of diamond with respect to glass is equal to 3 by 2. How much is 3 by 2? 2 ones are 1.5. And you know that refractive index has no unit. It is unitless quantity. Okay. Thank you.